Hey everybody, I've been doing a little bit of work on the game this week in my free time. I've just been working on three main things. The first main thing was the bullets and getting the collisions right and the sound pan. So that's all nice now, especially the sound pan I'm pretty happy with because that'll work on all sorts of things. So that'll be the first thing I want to demo, but I'll also be going through that in code. The other things are some of the UI stuff I've mentioned in the last video, which I'll just demo in the second segment. And then, yeah, I tried out the planes collision stuff, but it didn't work as I expected, so I've just kept the collision the same as the last video. And then the last thing, I've added entities which act as like enemies or NPCs or whatever, and for now I've just got the one model which I'll demo, and it has sound effect and just some basic stuff. So I guess I'll get into it. So first thing I want to demo is the bullets. So I've added sound pan, there's a random pitch for the bullet collision, the volume based on distance. I believe that was added in the last video, but the sound pan itself I've got working correctly, so I won't talk for this duration and just let you hear the pan effect. So as you hear there, it's based on where we're looking. Originally I implemented it and it was only working based on if you're looking forward, but now it's based on the player's aim direction. So what it does is it gets two vectors. One is the vector from the point where the bullet collides with the wall to your player, that's one vector, and the other vector is the vector from your target to the player. So with those vectors, first I got the angle, but that you don't even need to do any of that. All you have to do is get the vector cross product and use the y axis of that vector cross product of those two vectors. But I'll demo that in code anyway, what it looks like. So the other thing I've changed with the bullets is instead of using the bullet's position for OBB to OBB collision, so yeah, for OBB to OBB, I was using the bullet to wall collision, which, yeah, as I was mentioning in the last video, if the frame rate is low, but the velocity is high, it may not detect that the bullet collided with the wall. So like, let's say the bullet moves super fast. In one frame, it's in this position. In another frame, it's in this position. So because of that, it doesn't detect a collision, so you don't hear the audio, all that. But now I'm using the bullet's delta, which is just simply a vector from this position to the next frame's position, and then detect if that vector is colliding with the OBB, and then also using separating axis theorem. So it's close to, so I couldn't get ray to OBB working, but the vector to OBB is closest thing to ray to OBB. But the good thing with vector to OBB is the vector has two vertexes you can use for separating axis theorem. One is the start position, two is the end position. So with all that, yeah, it can work the exact same way as OBB to OBB. So that was the one change, and it works every time. So like if we, yeah, even if we move close, but this, I just realized this will cause issue like that. The bullet will be deleted before the sound effect can even play. So I think that's what's causing that pop noise. But given some time. So yeah, I'll have to fix that pop, because yeah, the bullet and the sound effect entity is deleted before it even plays. right when you stand right up to it. So that was the main things. I think I showed the volume when you're further away. Plays a bit quieter. So now sound pan, volume is all working. You've got the random pitch for the bullet collisions. So yeah, that's the demo of the bullets. Right, so for the bullets, the first thing I want to go through in code is the change now from OBB collision, like bullet OBB, to say wall OBB, instead of checking that, using the vector of the bullet instead. So here, like with this anyway, it's just going through the grid of the bullet and then checking the models in the coord for each of those grid cells. So like that current grid, the grid to the right, grid to the left, and so on. So just doing that, and then check vector change again of the bullet against those models in the grid. So that's this here. And here, vector to OBB, yeah, it's similar to OBB to OBB. So what I'm doing, I'm passing in the model. The moving model is the bullet. So I'm still passing in the model itself, and then the model of the say the wall. And then we're doing a vector to OBB, let's say here. Now, instead with OBB to OBB or AABB to OBB, we're using the axis of both objects. So like here, the ABB 3 axes there and the OBB 3 axes, or the two OBBs, OBB1, OBB2's axes. But for vector to OBB, you only need to do the axes of the OBB. So here we get those 3 axes, and then we check the overlap on axis. So here what we're doing is we're getting the intervals again, similar to all the other ones. So we get the interval. So I'm still passing in model render here, but if we go into this, get interval moving model, what we'll see, so this is for the vector, but what we are getting is a new vector of size 2, which is the starting position. So the models, so the bullet's current position, and then another one which is the, let's say, the future position, which is the position plus the velocity of the bullet. And that's, yeah, vector 3. And then with that, we're doing the same projection against each axis of the OBB to determine if there's a collision, as you would separating axis theorem for the other stuff, OBB to OBB. So yeah, really straightforward. So you can do that with vectors, but yeah, array to OBB, I couldn't figure it out, because you can't do that. There's no kind of start to array and end to array. It's just a long. So yeah, anyway, that's now what I'm doing for the bullet collision. It's using the delta instead of the OBB position. So the other thing with the bullets, and with, I guess, any models that'll use it, is now there's the sound pan that works correctly, and sound volume, I think, was implemented in the last video. But yeah, we're just getting, for sound volume, we're just getting the distance. I'm just doing divide by 50. It's pretty arbitrary. I'll probably adjust it anyway. But yeah, all you need to worry about is 1 minus this distance. Because, well, with the framework I'm using, Monogame, the volume will be from a float from 0 to 1. So it's just simply that 1 minus this distance. And then you can clamp that from 0 to 1. So yeah, here I'm using mathhelper.clamp. So that's just for volume, but for pan. So what I've done here is we have 2 vectors. We have the player aim vector and we have the difference vector. The difference vector is the position that the bullet, let's say for the bullet, where the bullet hit, minus your current position. So this also works for like an entity model. So it's the position of, even where that entity is minus your current position, and that's a vector difference. So with those two vectors, so here we've generated the difference vector and we just normalize that. But then for player aim, we use that usual rotation calculation. So like the cosine of the angle multiplied by the forward vector x minus the sine of the rotation by the forward vector z, and then that's your x plus that to your x, and then for your z is minus equals sine of the rotation multiplied by the forward vector's x, and then plus the cosine of the rotation multiplied by the forward vector z. So with that, you'll have two, so with this anyway, camera rotation is a unit vector as well, but both unit vectors, you'll have difference and the player aim, and then what we do, we just get the cross product of those two vectors, and simply we're just clamping this vector cross, we're using its y-axis, so that may be a value from, you know, -10 to 10 even, and then just clamping it between -1 and 1. And with that clamp, that's for Monogame, it uses a pan float value from -1 to 1 to determine if it's like -1, I think it's completely in the left, or it could be completely in the right, or if it's a 1, then it's completely in the opposite, or if it's a 0, then it uses both like usual. So that's simply the code you need to get the correct pan based on your aim. So that's the code for that. So I think that was it. Yeah. So that's it for demo for the code for the bullet collision stuff. Next thing I want to demo is the new model. So I will just let it, because it's a reference to something I was looking at, and use the actual model that it references as well. So I'll just go into it and you'll see for yourself. So yeah, I've added this rat entity. So the model itself is, there's this video from ages ago I saw, they were looking for what game this model came from, and I've just followed the trail with that, and because they found out who made the model, and they have a Creative Commons license with that, so it's usable. So I wanted to add the model with its textures into the game, and yeah, at the moment just added a random rotation, well, just a rotation in every plane, and yeah, it just has a move speed of 10 in the Z axis. So I have to still add like some basic AI and probably have it follow you around or something until get some proper AI in the game. But yeah, and also what you're hearing is what I was trying to show as well is the sound panning on it as well with the pitch, but it's just using a crow sound effect for now until I get a rat sound effect, and then I'll replace the crow sound with the rat sound, and that just plays at random intervals from 1 to 5 seconds. It was just a demo, the effect and that. So yeah, that's just a new entity which has a model, and then it has the usual, so that entity could be an enemy or an ally, or probably just like this neutral. The rats will be neutral, roaming around the levels. So I'll just show you again. yeah, so that's the rat model and sound effect and all that. The last thing I wanted to demo was a lot of the UI work and save and load functionality stuff. So the save, so this was one thing that I mentioned. It wasn't implemented yet in last video, but if we override this one, it moves it to the top. So that's the same in the load as well. So that, yeah, look at tree 2. And the other thing, if you notice, so I'll do, look over here. And then if we go over here and load it again, it preserves now the rotation as well. And then, yeah, bullet rotation preserved too, because that was another thing. So yeah, rotation is all preserved now on the load states. And then on this menu, it's got the continue game and quit to main menu here now instead of quit to main menu there. And yeah, you can just click that to continue instead of pressing escape. So that was the main things for UI functionality and stuff. Yeah, and the other thing now as well, it wasn't doing autosave on quit to desktop, so it's doing that now too. So that was the last things I wanted to demo. Thanks for watching, everyone. So I did a little bit this week. I'm pretty happy with getting the sound pan working. It took me a lot longer than I thought it was gonna, but yeah, it worked. And same, I tried the planes for the player to model collision stuff, but it didn't work. And yeah, it was a bit of fun getting that rat model in. It was the first kind of like enemy or entity added to the game, and yeah, with a bit of fun with the sound effect and the crow sound. So yeah, got a few things added as well from the last video that I wanted to add. So yeah, next week I'm not sure what I'll be working on, but hopefully I'll have some good stuff to demo then too. So thanks for watching and see yous.